friends, Mrs. Mapes here with another science experiment. Today we are going to be experimenting with water and density and temperature. So going with the scientific method, the first step in that is to ask a question. So today's question, what happens to water's density if the temperature changes? All right, second step in the scientific method is to do some research. So I did some research on the internet and this is what I came up with. When water becomes hot, it is absorbing energy in the form of heat. The absorbed energy makes the molecules in the water move and expand, therefore decreasing the water's density. The hot water has fewer molecules in the same volume of water with something that's room temperature or cold. So the hotter the water, the lighter it is because the less dense it is. The opposite is true for cold water. So the more dense the water molecules are, the closer together they are, the colder the water is. When the molecules are really close together, they're absorbing less energy and they don't move as much. This means that the cold water compared to room temperature has more molecules in it. Therefore, it's heavier and will sink. Okay, so third step in the scientific method is to form a hypothesis. So today, I am going to predict that in room temperature water, cold water is going to sink down to the bottom, and hot water is going to rise to the top. Through my experiment, we're actually going to do two separate experiments today, and Melody is my helper. We're going to do the cold water experiment first, and then we'll do the hot water experiment. These are super simple. All you need is some kind of clear glass container. For the cold water experiment, you're going to need an ice cube tray, and you're going to need to do some food coloring and freeze some ice cubes. For the hot water experiment, you're going to need like a small bottle. I'm sure, look around your house, that has a small hole. We're going to be putting hot water in it. And then, of course, you're going to be needing food coloring. All right, so I am going to switch it over. Melody's actually going to be doing the experiment with us, and I'm going to be talking her through it. All right, here's Melody, and she's ready for the cold water density experiment. So all she has to do is put a blue ice cube into that water. Now notice, the ice cube is floating, friends, but what we want to see is the blue. As the ice cube melts, that cold water is going to start sinking to the bottom. Oh, let me try to zoom in here so you guys can see. Now remember, the water is room temperature, so it's not going to melt the ice cubes fast.
As it would with hot water.
Yeah, as it would with hot water. But I can definitely start seeing right here on the side of the jar. Melody, do you see it? You see it on the bottom?
I can see it on the top.
You see the blue water that's starting to just creep around on the bottom there?
Mm-hmm.
Friends, that is showing us that cold water has a higher density. It is heavier. Do you guys see the water, the blue down here? So as the ice cubes are melting, that cold water is starting to sink down to the bottom, below the room temperature water. This is really, really kind of cool.
Yeah, it's like smoke going down the bottom.
It looks kind of like smoke, yeah, like smoke's kind of like hanging out down at the bottom. Now, as the waters become the same kind of temperature, what do you think is going to happen to the water, Melody? Do you think that blue is going to stay at the bottom?
No, it's going to be all blue.
The whole thing will eventually become blue, right? But right at the beginning of our experiment, you can see as that cold water is coming off of the ice cube, it's sinking down to the bottom because it has a higher density.
But along the sides, I can see like blue, like tealish.
Yeah, but you can clearly see right here on the bottom, the blue. Now, obviously, too, friends, you want to make sure that those ice cubes have a lot of food coloring in them to get more of a powerful effect, right? Mm-hmm. So cool. Okay, are we ready to do the hot water one?
Yes.
All right, so this experiment, are you going to do the conclusion, Melody? What happened?
It went to the bottom.
It went to the bottom because it's
lower density.
It's heavier. It has a higher density, right? It's more dense than the regular water. Okay. Okay, friends, so we are ready for the hot water portion of this experiment. So what we did was our hot water comes out really hot out of our faucet. So we ran that water for a while, made sure it was at its hottest temperature, and we filled the bottle with hot water, and then Melody just added a whole lot of red food coloring. So we refilled the glass jar we actually added cold water to that because we really want a contrast in the temperatures to make this experiment work. Now, hot water is going to be less dense, so it's going to want to stay at the top of the water, but you will see it actually ends up mixing with the rest of the water a lot faster than the cold water did with the blue. So this is going to be a quick process to see what happens. So Melody is going to put the bottle that is open, so the top of the hole of the spout is open. She's going to just float that right on the top. Nope, Melody, put the whole bottle in. Nope, yep, exactly. Put that whole bottle in, and I'm going to zoom in to see what happens. Let's see. What if we take this and we start, you guys see the red coming out of the bottle? I'm just slowly kind of squeezing the bottle. Melody, you want to take over? Perfect. Oh, that's good. Mel, good. Stop. Let's see. Is that hot water is going up? It's rising, guys. Can you see that in the glass? You see the red all at the top? It's hanging out there because hot water has less density than cold water. It is lighter than cold water. You see the red? Okay, that's enough, Mel. See it? Mm-hmm. So eventually, what's really cool though about hot water is those molecules are moving. They're moving a lot. Remember, that's what we talked about at the beginning of the research? So moving molecules mixes the water a lot faster than slow moving molecules. So that's why that reaction, it ends up actually dissolving and mixing in with the room temperature water. So now what color's our water, Melody? It's a nice what?
Orange.
Orangey pinkish color, yeah, but it's all kind of mixed in.
But if we add more, it's going to be more of a red.
You can try adding, right? Yep. So friends, what you want to, when you're doing this portion of the experiment, what you want to avoid is actually squirting the bottle from up here. You want to actually submerge the bottle a little bit and then squirt the red in to really get a good reaction of the red sitting at the top. Like I said, it's a quick glance to see the hot water floating up, rising up because it's less dense. Okay, friends, so that was kind of exciting, right? Science is exciting. I drew a picture of kind of what was happening, the difference between hot water and cold water. So we have these molecules, right? The water molecules, and cold water, there's a whole lot more water molecules packed into the same volume of water versus the hot water, there's less molecules. So the more molecules you have, the more dense it is, the higher density. The less molecules you have, the hotter the temperature of the water, and they're spaced out and they're moving around, the lighter it's going to be. So our experiments today proved that cold water sinks, hot water rises, and this is kind of leads into the whole water cycle we could get into. It's the same thing with air. Hot air rises, cold air sinks. So density is a really, really cool thing. And so I just want to recap our final step in the scientific method. The conclusion is hot water has a lower density, therefore it is lighter and will stay afloat. And the cold water will sink to the bottom because it has a higher density. It's heavier. Have fun trying this experiment at home. And make sure when you're using the hot water that you want to submerge the bottle and kind of very slowly push that hot water in so that you can see it rising. Have fun, friends, and see you soon.